Assalamu alaikum respected students. In last video we were discussing about the van der Waal equations. Van der Waal equation basically it is the modified equation of the general gas equation. General gas equation basically used for the ideal gases, and van der Waal equation used for the real gases. After some modification, van der Waal equation was established. The question was asked, y term n square a over v square was added in the pressure, y term nb subtracted from the volume in the general gas equations. What is the reason behind this? In last video we have discussed about the pressure, why the a n square or v square was added in the pressures. Basically van der Waal equations was established on the basis of the two faulty postulates of KMT, that is known as kinetic molecular theory. These two faulty postulates became the foundation of the van der Waal equation. One faulty postulates, there is no force of attraction between the gas molecules. This point became the reason for the correction in pressure, or in other words, for the addition of this factor a n square or v square in the pressure. And other faulty postulates is actual volume of the ideal gases is negligible as compared to the total volume. But in real gases, actual volume cannot be neglected as compared to the total volume. So NB factor is subtracted from the volume. This factor we have discussed already. In this video we discuss why NB factor is subtracted from volume. Let's go. Why NB is subtracted from volume? According to KMT, actual volume of ideal gas is negligible as compared to the total volume of the container. This point is only valid from the ideal gases, not for the real gases. Suppose that is the volume, that is the of container, volume of the vessel. These are the molecules of the gases. At the first sight you consider it the ideal gases. If we compress these molecules, after compressing the molecules, the volume of the gas molecules is known as actual volume. The actual volume after compressing, extremely compressing, will be negligible as compared to the total volume. But it is the theoretical point, not the actual point. But in real world, when we compress the gas in the container and we applied the pressure and more and more and more, at some point we cannot compress further the gas. This volume that is occupied by the gas molecules is known as incompressible volume. It is also known as excluded volume or effective volume, represented by B. This excluded volume cannot be negligible as compared to the total volume. If we wanted to calculate the V free, one thing which must be added at this point, basically PV is equal to nRT is general gas equation, that is the V basically that is the V free. Total volume of the gas, total volume of the container is equal to the V free. V free, that volume which is available for the free movement of the gas. Okay, if we negligible the actual volume, then all volume is V free. But in real gases, if we want to calculate the V free, we must subtract this part, that is the excluded volume, from the total volume of the container. Then we will calculate the V free, otherwise it is impossible. So if a factor is subtracted from the V free, Okay, that is the V free from that is NB. N is the number of moles of the gases in highly compressed form, and B is the excluded volume, that is the volume occupied by the 1 mole of gas in highly compressed state. Okay, that's the reason the factor NB is subtracted from the volume. Okay, I hope so you got my point related to the van der Waal equations.